People often underestimate the total scale of 3D printing, but giant print farms and printing in general is actually able to produce millions of pieces. So let's talk about how that's actually done. So first off, let's look at how parts have been mass manufactured in the past. When you're looking at plastic pieces, very often the first option that you look at is injection molding. Injection molding is where you literally carve out the shape of an object into a brick of steel, and then you shoot plastic into it, and the part falls out. This is a really efficient way of making parts because it allows you to make the exact same part over and over again with a very simple process. But the downsides of this process is that it's very expensive to get started. It costs a bunch of money to carve something into a block of steel and to do it with precision and reliability. And in order to pay off that block of steel, you have to produce hundreds of thousands of parts. So whether you actually sell hundreds of thousands of parts or not, you are still stuck with the block of steel. So it's a big risk and a big upfront cost. 3D printing benefits from the ability to just put in electricity and plastic and you get the final part out. So theoretically, it should be a better way than molding because you don't have a big old hump financially to get over, and then the parts, you just get the parts. But 3D printing has often been pegged as something that can't produce thousands or millions of parts, which is just simply not correct. Now, the very first way that you reduce the cost of 3D printed parts is by reducing the cost of the materials. Now, in injection molding, you have raw beads, stuff that basically just came out of an oil well, can go into an injection molding machine. It's very low refinement and very low effort stuff to make. And plastics as a whole are a large commodity, so you can buy trainloads of this stuff, which makes it very cost effective so you can produce lots of parts really cheaply. 3D printing, however, suffers from filament, and filament historically has been very expensive. Whereas injection molding can buy plastic for like $1 a pound, 3D printing buys filament at like $12 a pound. But this isn't an issue anymore. At large print farms like ours, we actually have interior extrusion capabilities, so we're able to take those beads, add just a little bit of power to them, and turn them into filament. So the cost of the raw material can be quite low if you're at the scale that justifies ramping up the plastic in those other machines producing it. If you're producing like sub 1,000 parts, then you're kind of dealing with off-the-shelf kind of things. But if you're making a commodity part and you're like, we need 1 million of these this year, then we just run up that filament and are able to make it very cost effectively for you by just extruding it out and kind of pre-digesting it for the 3D printers. Another thing that people always point to with 3D printing is the actual cost of the part itself. And this is kind of a misnomer because, of course, if you're making 100 parts, then it's going to be more expensive than if you make 1 million parts. And most people don't ask to have 1 million parts quoted. So they say, oh, the 100 parts, it costs $1 a piece. Well, there's no way I can pay you $1 million to make 1 million of them. But that's just incorrect because it doesn't take into account the economies of scale. If you ask for 1 million parts, the cost drops dramatically because all the systems around it are able to adjust and just run those parts. I'll give you an example. Like when we are working with a client and they need 100,000 pieces, what they will generally do is say, we need 100,000 pieces. And then we will come back and ask, over what period of time? Do you need them all in 30 days or do you need them this year? So if you need them this year, it is more cost effective to produce 10,000 parts a month rather than producing 100,000 parts all at once, because that allows us to basically dedicate a section of machines to it that just continuously run that same part. So everything is more efficient. You keep those machines loaded and tuned for that part and that kind of thing. It just gives you so much more efficiency. So the cost of 3D printing really isn't a factor because if the cost of material is down low because we have internal extrusion and you have a good setup and production process around it, you can make it very efficiently. Because again, printing can grow the part, shove the part off, move on to the next part. So that's fine. There's not really any fundamental factor that makes 3D printing more expensive than anything else. Now, what a lot of people always point to is they worry about the time of the part. They're like, 3D printing can't make 1 million parts, it takes an hour per part. There's no possible way you can make that many pieces. But that's simply incorrect also. In order to produce 1 million parts, again, it's dependent on the timeline, but let's take 1 million parts. Well, if it takes an hour per part to make it, if that is indeed the case, and it always varies on the parts, if it takes an hour per part, okay, you have 1 million hours of print time to do. That does not all have to happen on the same machine. This is the beauty of 3D print farms. We have thousands of machines that can produce these pieces. So in like our mega farm, that's spec'd out for 3,000 machines, we could take 1,000 machines and we would be producing 24,000 parts per day, because they can run 24/7, because again, they're automated and you don't need attendants to them. If you're making 24,000 parts per day, you can knock these things out very quickly. You can produce that full 1 million in just about a month. Print farms allow us to parallelize these jobs, to break them into small sections so that many machines can work on a single goal rather than one large machine. And this improves reliability in supply chains, because you no longer have a supplier with their big, fancy, expensive machine that when that machine breaks, your parts are now late. If one of our machines break, it's like, oh no, well, we gotta go grab another machine. So the scale is very easy to get to if you have scale. Again, we have all the machines available so that parallelization can occur. So how do you make 1 million parts with 3D printing? Well, a lot of the work is on us. We reduced the cost of material. We designed machines that could be automated and efficient so they can run 24/7. But then it is incumbent upon the customer to design a good part, plan for the process, and understand that if they want to get the scale out of 3D printing, they have to provide scale. Many people make the mistake of sending 10 parts to the printers and then going to the mold. But if they sent the 1 million parts over to the printer, very often it can be done. And then you're able to design for printing, you eliminate the whole cost of the mold, and you're able to take advantage of the scale, speed, reliability, and material supply chain that printing is able to use. So we got to 1 million parts by using existing plastics, creating a highly automated system, and then building the system and processes around it so that you can get real scale. Because who cares if it takes an hour to make a single part if you can still make 24,000 in a day? Have a great day, everybody.